Hello, we are discussing about GATE 2010 ECE paper for parallel RLC circuit. Which one of the following statements is not correct? So first we will see the characteristics of parallel RLC and later we will discuss about the answers given. So this is the simplest parallel RLC circuit where the R, L and C all elements will be in the parallel. If simply L and C are in parallel, that is also called as parallel RLC circuit only, but this is the simplest one. And the characteristics of parallel RLC is parallel RLC, in parallel RLC circuit at resonance current is minimum and impedance is maximum. Impedance is real and maximum. Real means there is no J term, imaginary term. That means at resonance inductive reactance is going to be same as capacitive reactance. So Z is going to be equal to R itself. And next, at resonance, the resonant frequency can be calculated as angular resonant frequency is 1 by root LC, where the units are radians per second, and frequency is going to be FR, that means 1 by 2 pi root LC, where the units are hertz or cycles per second. And Q factor for parallel resonant circuit is resistance divided by reactance, whereas for series resonance circuit it will be reactance by resistance. So this is completely opposite. Q factor for parallel resonance is R by omega L, that is resistance by reactance, otherwise R by 1 by omega C. So that you can write it as omega CR. And omega is equal to root LC. This omega is nothing but at resonance only. Omega R. If you substitute omega R is equal to 1 by root LC, either in this equation or in this equation, you will get this as Q factor is going to be R times of C by L. You will get this is Q factor. And bandwidth of parallel RLC circuit, bandwidth is simply omega R divided by Q, or simply you can write it as FR by Q. If you are writing FR by Q, you can write F2 minus F1, that is bandwidth, that you can write it as FR by Q. Otherwise omega 2 minus omega 1, which is also bandwidth, by that time you can write it as omega R by Q. So here bandwidth can be referred, both are going to be same only. This is also bandwidth, this is also bandwidth, but the units are going to be differed. It is in hertz, it is in radians per second. So both will be giving the same value, because if you multiply with 2 pi both sides, then you will get this expression. So multiplying with both 2 pi doesn't change the value. So bandwidth will have the same value whether you are going to use this equation or this equation. So omega R, if you are going to use omega R means 1 by root LC. Omega R means 1 by root LC divided by Q value is R times of square root of C by L. So R into square root of C by L for Q. If you substitute this one, you will get this as bandwidth is equal to 1 by RC. You will get bandwidth is equal to 1 by RC. So these are the important characteristics of parallel RLC circuit. Now we will go for the given question. For a parallel RLC circuit, which one of the following statements is not correct? First one, bandwidth of the circuit decreases if R is increased. That is, from this expression, as R increases, denominator part is going to be increases, so that bandwidth is going to be reduces. So first one is right answer. And bandwidth of the circuit remains same if L is increased. So as L increases, bandwidth is same, doesn't affect. Bandwidth doesn't affect because bandwidth is independent of L. So whether L increases or decreases, bandwidth doesn't affect because bandwidth is not depending on L value. So that bandwidth will be remain same if L increases as well as decreases. So second one is also right. Third one, at resonance input impedance is a real quantity. At resonance input impedance is a real quantity, real and maximum for this resonance. So this is real quantity. Okay, this is also right. Next, at resonance the magnitude of input impedance attains a minimum value. Magnitude of input impedance is maximum, but it has given as minimum value. Okay, so this is going to be the wrong answer. So the right option for this question is D.